Hey guys, welcome to the shop. Now, this week we're going to be working on our clutch shaft out of our large K&T mill transmission. We need to find where the slot's at. We need to drill and ream our hole for our little roller and spring detent. There's a lot to do, and I'm ready to get this thing back together and use it. So let me bring you in. We'll get set up on the surface plate. We'll find this hole and we'll get set up in the milling machine and hopefully make some chips. So I'm filming with the GoPro Hero 7 that was given to me. Well, I went in with him on it. Robert Watson. So thank you, Robert. I really appreciate it. And hopefully I can get better at using this thing. It's definitely different than what I've been used to. I filmed several things last week, but I filmed it in the wrong aspect ratio and basically decided not to post. But it wasn't a lot anyway. I was busy last week. Me and my son went deer hunting and we were successful. We got a small doe, which was great. So now I got some meat in the freezer and I took a little time off. So here is our roller that goes in our slot and our pin. That's a 5/16 pin, and it's got a little wear on it. I don't know if you can see that or not, but little wear. I can just barely feel it with my fingernail. So we're going to be replacing this 5/16 pin. The roller looks to be in good shape. Here's the detent that slides in this slot and goes over this little roller. So here's our new shaft, the one that we made a week or two ago on the shaper. We cut all these rack teeth, so if you're interested you can go back and check out that video. But we need to put that slot in this one. We need to find out where it is on this shaft so we can, you know, accurately place it on our new one, and hopefully this thing holds up. I think that it will, but you know, we won't know till we try. So we need to measure these holes and see what they are. This 5/16 dowel pin, I drove it out with a standard punch and brass hammer, so it wasn't in there all that tight, but it's a loose fit on one end and a tight fit on the other. So we're going to have a press fit on one side. So I'm going to measure these holes, see what they are. And for that I'm using my Starrett small hole gauges. These things are really nice. You can get them cheap. These were basically brand new. Bought them off eBay. I think I paid $25 or something for them. But in order to use these, you just slide them down in the hole and they expand with have a little taper in there, and they expand when you tighten this little knob here and give you resistance in the hole, and then you measure across that with your mics. I already showed my patrons me using these for this exact purpose. So just put it in the hole. This is the large side. So I get a little resistance. And then I transfer that feeling over to my mics. So I just want to rock it in between the anvils of my mic. And it looks like that larger hole is, you know, 315, 316. So we're going to have to drill that out. Then I'm assuming for a press fit for a pin, we're probably going to go half thou undersize. So that's pretty easy, you know. So we need a 312 thousandth reamer. So let's see if we can find that in my reamer drawer, and then we'll get set up on the mill, and then we will hopefully make this slot. But we first got to lay it out on this one. Alright, so I took and drove a dowel pin into the press fit side of the hole. Excuse me. Took a little angle plate and my square off the plate because this rack is 90 degrees to this hole. So I took my height gauge and swept this pin just to get the top of it. So now I need to subtract half of this pin from that height, and that'll give me the center height of this pin. And it happens to be, what, 880 thousandths off the top of the plate. So 880 minus, what is that, 312.5, so that 156.25 equals 723 and 7.5 tenths. So I'm going to dial that into my height gauge. I'm going to blue up the new shaft that we made and transfer that mark. Then we got to find it. And this, we got the height. Now we need, you know, how far off this shoulder. I would have to say that I definitely like the GoPro, but if you're going to buy one, you might as well factor in the cost of, you know, several batteries, because they are battery hungry, and get the charger that charges multiple batteries at one time. Otherwise, you'll be waiting on batteries to charge. So I'm just going to glue this up, let it dry, and then take it back to the plate. We'll scribe our one line on it, and then we'll find the other. And then hopefully we can get set up in the mill and get this slot cut, and maybe try to find our tapered pin location. That's going to be kind of interesting. So not for sure what I'm going to do about that, but we'll figure it out. So let's let this dry, and then we'll scribe our lines. Alright, so we're going to hold everything still on my setup here, and bring in our height gauge and scribe our line. Alright, so it's light, but I can see it good, so that'll work. Now let's find from the shoulder. Alright, so I'm just going to come in and sweep this pin. And then I'm going to take the measurement that I get, minus half the diameter of the pin, and then transfer it over to our new shaft. I think that will be close enough, I believe. So there's where our hole needs to be. And I'm just doing a visual to make sure before I cut anything. And that looks pretty good to me. So now all we need to do is get set up in the milling machine. Find a setup that'll work for this. And first do some practice pieces. I've got a piece of this material that I want to ream some holes with, just to make sure that my reamers and stuff are, you know, doing what they should. And then we will put the hole in this shaft. Alright, so I need to tram in this vise. It has not been trammed in since the last time I stuck it on here. Stuck it on here for something rough, I remember, and didn't need to tram it in, so you always should check it if you're not sure. But I'm going to show you guys how I tram in a vise real quick. And I always use a tenths indicator. When I bought this thing, I'm like, you know, I'll probably never use it, was the thoughts in my mind, but now it's basically all I use. Anything, you know, more gross than this, as far as its sensitivity, you know, I don't really like. For, you know, especially for tramming in, you know, your reference surfaces, I want them to be as close as I can get them, because I'm anal like that, I guess. But anyway, and I sweep across the face, just zero it like I did. Sweep across, my needle is dropping, so I know that this side is low. Both of these nuts are tight. I'm just going to loosen one. and the needle continues to drop as I traverse across. Now, I can't just split the difference because my pivot point's all the way over here. So, all I do is start on, well, we can start on one side or another, but I'm going to go across. My needle is dropping. Tap on it, keep moving. It's still dropping. Tap on it a little more. Watch the needle. And still dropping just a little. This vice jaw needs ground, but we're in a bad spot now. Let's go up a little bit. Sweep across. Yes. So I mean, within 1/1000th of an inch, basically, right that quick. Drop in. So that's how quick you can tram in a vise. This looks like it's a 10th indicator, so we're within 1 thou right there. So I'm going to snug it down a little bit. Not completely. Back across. Still slightly dropping. And, that's pretty good. 1/2 thou, that quick. I mean, you could sit here and get it closer, but for what we're going to do, it's not going to be needed. So that's how quick and easy tramming in a vise is. A lot of people, what does that take? A minute? If you practice that a little bit. Here's something I bet you guys don't see every day, at least most of you. This is a large 50 horsepower gas compressor. It's not an air compressor, although it does basically the same thing. This compresses a sample from our process and compresses it to where we can, analyze it and see what's in it. So this is a big diaphragm pump. It has a metal membrane that separates our gas coming in from the actual compressor and stuff, because when you're taking a sample and you analyze it, you do not want contaminants from the compressor, the oil and stuff like that, to get inside of your sample. So this is a diaphragm pump, big 2-cylinder, 2-stage, and we're tearing it down because we're seeing metal fines in the oil and stuff, and that's never ever a good sign. I mean, it's really fine stuff, so we're not exactly for sure what the culprit is, but something in this thing is coming apart, and we want to catch it before anything major happens. But give you guys a little look inside the crankcase. We already wiped this is the oil box where it pumps oil from. We already wiped it out, but let me show you inside the crankcase, and you can see some of the black goop and debris that we're seeing. There are the 2 end caps for the 2 connecting rods for the 2 cylinders, and if you look in the bottom there, you can see the black, it looks like soot, but there's a lot of metal and stuff in it. We've run a magnet through it. Our filter had a lot of metal and stuff on it, our strainer. There is a loop hanging right there. It's the same color as the paint on the inside, but it's a loose piece of RTV. This is actually a rebuilt unit, and you got to be so careful with that RTV. That stuff can get in your oil passages, in your coolant system or your vehicle, and cause all kinds of problems. I've actually seen engine failures because of RTV sealant. So I know people like to apply that stuff heavy, but you got to be real careful with that stuff. It'll cause you more problems than it helps in a lot of cases. Some of this stuff's not even made for RTV, but people seem to want to put it everywhere anyway. So yeah, that's what I'm dealing with today at work. Just a little look behind the scenes. I normally don't show too much of this stuff for various reasons, but yeah, this is what I do for a living, and I spend way too much time here. Alright, so I got a little hot plate here and a half of a beer can with some paraffin wax in it. This is Gulf wax, just straight paraffin that you can buy at almost any store that sells canning supplies, or grocery store even. And what I've been doing is going through my reamers. I already done almost all of them, and taking them and dipping them in the paraffin. So heat the paraffin up just to where it's a liquid form. If it's too hot, it doesn't coat these reamers well. But you don't have to just coat reamers. You can coat end mills or taps. All the same. So just a way to protect them without having to use the sleeves that a lot of times they ship with, which I think is probably the best way to keep them, but they take up more space like that, and a lot of us don't have the luxury of getting them new. Most of these were either sent by viewers or bought secondhand in a bag at a flea market or who knows. But opening the drawer up and open and closed all the time, and these shuffling up against each other definitely can damage the cutting edges. And I think this is a good alternative to the commercial kit that like they use when they sharpen end mills and stuff. There is a peel coat or whatever it's called. There's one that has the professional stuff on it, I guess, and this stuff does peel off a lot easier than the paraffin, but this stuff's cheaper, I can guarantee it, and I don't have to go searching for some obscure item that you probably can't find. So get you some paraffin, a little hot plate, and you can save your cutting edges on all of your tools. I've done a lot of stuff like this, but it makes a good coating, and it peels off relatively easy. I mean, just with a fingernail. It doesn't take long. There you go. And it's protected mine up to this point pretty good. I've been doing this for about a year. Now, on my reamers, you can see they all almost have a little blue tag on them with the size, so I've identified them, and I also went and took all that information and put it in a little book, little notepad. That way I can refer to this to see if I have the reamer I need. It saves me from having to dig through all these reamers in order to know if I even have it or not. I still got to dig through to find the reamer that I need, but at least I'll know if I'm wasting my time or not just by simply looking in the book. So it takes a few minutes, but just some heavy tape and a Sharpie, and it's worth it. So just a little tip for you guys. I showed this to my patrons not long ago. So let's go over to the milling machine. Let's drill and ream this hole and get this part of the shaft done. But you want it just to where it's melted, that's all. Anything more than that and it doesn't seem to coat really well. But I mean, you will get a really thick coating on them if you got your paraffin at the proper temperature. And it sets up almost immediately. Even done all my small ones, so everything but my tapered reamers. pretty nice. Alright, so I've got a parallel in my vise, and I'm going to be referencing off of the rack that's on this. And I've got quite a bit of stick out here, so I need to take care of that too. So I'm going to be drilling the hole right on our spot, and I center punched it, and I got a wiggler in here so I can line up on my spot. I'm going to take a machinist jack and set under the shaft here. And I don't want to push up on it, I just want to, support it. I don't want it deflecting. These are really handy. I don't see a lot of people use them much anymore, but definitely a handy tool. Put it in and line up on the hole. Consider that close enough for a spring detent. No reason to get too carried away. And now we need to, because we're drilling off center, if we was to just take a drill and try to drill that hole, it'd go all crazy, and we'd end up with a crooked hole for sure. So I'm going to take an end mill that's slightly smaller than our final reamed hole, and I'm going to make a flat on it. I'm going to raise this table up a bit, and then we will make our flat and ream our hole. Now we need to center drill it, and pilot drill it, and drill it and ream it. Alright, so now we got a good flat here with the face of our end mill, and we're going to take our center drill and start us a good straight hole. That way, the drill would hit this rounded surface or this radius and walk off to the side otherwise. Pilot drill it. I always like to go through with a small drill. It just makes your drill cut better, your final size anyway, and it seems to follow the hole that you pilot really well. Alright, so this is 311.5, so it's 1,000th under our 312.5 pin that we're going to be pressing in this hole. The drill that we just drilled our hole with is a letter N, and it happens to be 302 thousandths. So that gives us 9.5 thousandths. If this drill drilled that hole perfectly to size, that's what we would have. And the allowances in the book say anywhere from 5 to 10 thousandths on a chucking reamer. So that's what we're doing, and it worked on our test hole. You know, I recommend doing a test hole before you do your final reaming, because it makes a difference. Just the material, the cutting fluid you use, the phase of the moon can give you a different hole. And I'm not using a floating reamer holder, so you know, we're using what we got. I don't own one, so hopefully this will give us the hole we want. And that is too fast. That's more like it. Just slow and easy, and lots of oil. There we go. Hopefully that gives us the size we want. It should. Well, I've got the old shaft here, and I'm again using the teeth to set on top of these parallels on the surface plate. And I brought my height gauge over and lined up right with the bottom edge of this slot here, because I need to mark it out on the new one. So I'm going to move that to the side, bring in my soon to be new one, and I'm going to scribe that line. Alright, now put this shaft back up here, bolt on or clamp on this lower finger accessory. And I'm going to come in and find the top edge, the tops of that slot. Okay. Pretty happy with that. No, that's got to be perfect. We're just trying to get it to match the old one, because it worked. And I'm going to scribe this line. So now we've got, hopefully you can see that, we've got the width of our slot marked out. Now we just got to mark the two ends, and that's easy enough to do. I'll just stand them up on the surface plate just like I found the height of the pin, and scribe them out. And then we got to decide how I'm going to cut this slot out. Alright, so I've run into an issue here, and it's just an issue with the equipment that I have. And what they've done on the slot is they used a 3-inch milling cutter on a horizontal mill, and they plunged it in and cut that relief in there. Now, this is the only 3-inch cutter that I have, and it's a 14 thousandths of an inch slitting saw. So I don't have the equipment to make this slot. Now I could grind it on the cutter grinder, but my spindle's not set up for, it's not capable really of heavy duty grinding. And I even pondered putting this on a faceplate on the lathe and making a custom cutter to, make that that radius in there. But I don't think it's going to make a bit of difference, to be honest. I mean, I haven't done a stress analysis on it, but I think it'll be fine just to cut this slot rectangular. And I measured this slot, and this is a 370 gauge block. This is a 375 or 3/8 of an inch. Now the 3/8 of an inch block does not fit in the slot, and the 370 slides in with just the slightest bit of wiggle. So I'm assuming it's been cut, this original slot, with a reground or a sharpened, resharpened milling cutter. So all I'm going to do, take a standard end mill, plunge in, cut it on the milling machine. Now, this could weaken this shaft. It may not. I'm not for sure, but there's one way to find out, and that's to try it. So let's go over to the milling machine, let's get set up, and cut this thing. Alright, so I got our new shaft in the vise here. I stare it square off the table, and just made sure that the tops of the gear teeth are parallel with the slot that I'm going to be cutting, because that's the way the original is, and that's a good way to do it, I guess, without having this hanging out of the vise and using the actual tops of the teeth to reference on the vise. So I just moved it back, squared it off the table. And I'd have to say that the rumors of my death for not posting last Saturday morning were greatly exaggerated. I took some time off. I had said in my last video that I was going to go hunting with my son, and we did that and had a great time. We were successful. We got a small doe, which is exactly what I wanted, to put in the freezer, because we eat a lot of deer and stuff. It's an abundant resource around here, and really they're overpopulated in this area, so it's a good thing. Helps out, helps me out, and helps the environment around here out, and as far as I'm concerned, because when a population of animals gets too high, they can get unhealthy, and disease can spread through, and you don't want that. So they try to keep the numbers lower than what they are of deer in this area. So we hunt every year and fill our freezer up. I'd still like to get another one, but one is better than none for sure. So I did film some last week. I just did not post it on my normal channel. I posted on my Patreon page, and I showed some footage from my place of employment and stuff like that, which I normally don't show. It's kind of touchy. But did post for them, but it was all filmed in the wrong aspect ratio, and edited also in the wrong aspect ratio, which, I'm not a real technical guy when it comes to cameras and footage and stuff, which may be surprising to you. It may not, but just a work in progress. New camera, takes a little time to get everything squared away. So that's it. That's what I've been up to, just spending some time with the family. I got another job here that I had showed a couple weeks ago, I think. It's a cast iron gear with some strip teeth. This goes on the extension from not a mobile home, but a RV. Some of them you can crank a handle and a whole room pops out the side. Well, this gear controls that, and it's for my father-in-law, Alan, and he needs it fixed because it's apparently not very easy to get this piece. So I'm going to be brazing up the teeth and grinding a cutter to cut those. Now, I don't think we'll get to that in this video. We may braze it up, I'm not for sure, but we'll see. And I need to cut that. I think I'm going to use the shaper and, probably the rotary table. So that should be interesting. But anyway, let's get to the task at hand, and that is cutting the slot. So I'm going to get milling cutter in, set my stops so I can just bump up against them and go back and forth and cut it to depth. And this shaft, other than pinning it to the fork, should be almost